in this example, or in this exercise, we want to show that the power set, or the set of all subsets of n, so n, also denoted by 2 to the power n, is uncountable. Okay, so we know that it is infinite. That's obvious because it contains basically a set that is one-to-one with the set n of natural numbers, which are the singletons, and assume not. So let us prove it by contradiction and say assume not. Then P of n is countable. Okay, and since countable sets are either empty, finite, or one-to-one onto or bijection with n, then this assumes, or this tells us that we can find, okay, then there exists a function f from n to the power set of n, which is one-to-one and onto, in other words, bijection. Okay, so now we consider the subset of n, a, equals n in n, such that n does not belong to f of n. So keep in mind that f of n is an element of the power set. In other words, that f of n is a subset of n, which makes sense to say that whether n belongs or does not belong to f of n. Okay? So now we claimed that f is onto, because it's a bijection. Okay? Therefore, there exists m, okay, in n such that f of m is equal to a. So we have two cases. Case 1, m belongs to f of n. Okay? So in this case, m belongs to a. Okay? And by definition of a, so m does not belongs to f of m by definition of a. So this would generate a contradiction. So we have a contradiction with the fact that m belongs to f of m and m doesn't belong to f of m. Case 2. So case 2, we have m does not belongs to f of m. So m does not belong to a, since f of m is equal to a. Okay? But by definition of a, and since m does not belongs to f of m, then m belongs to a. Again, contradiction with m does not belongs to a and m belongs to a. Therefore, since these are only the two cases possible to us, we proved that such f cannot exist. So therefore p of n is uncountable. And what's interesting in this proof, in fact, let's remark, okay, in fact what we proved is the following: if x is a set Okay, same proof, same idea. There's no way one can find there does not exist f from x to the power set of x, which is onto. In other words, p of x. Of course, we do have a one-to-one, huh? So x can be embedded into p of x in a one-to-one by looking at. We can consider the following, which is the singleton. Okay, for every little x, we consider the singleton x. So this is a one-to-one. Is one-to-one. Is one-to-one. What's not true, we cannot find an onto map from x into p of x. So, in other words, p of x has a subset which has the same cardinality as x, but it's bigger. See? So, basically, p of x is strictly bigger than x.